Hi, it's Professor Adam. Let's talk about empirical and molecular formulas. The empirical formula of a compound describes the simplest or most reduced ratio of the atoms in an element. The empirical formula for nitrogen dioxide and dinitrogen tetraoxide is the same, NO2. Being the simplest ratio of the atoms in a chemical compound, the empirical formula does not consider the arrangement or the number of atoms in a compound. It is the formula of choice, however, for ionic compounds such as magnesium oxide and macromolecules like silicon dioxide or silica. This is because they are typically made up of repeating units of the same empirical formula rather than discrete, limited entities like molecules. Returning to our first example, nitrogen dioxide and dinitrogen tetraoxide, they had the same empirical formula, but you may have noticed that they have different numbers of atoms. Nitrogen dioxide has 3, while dinitrogen tetraoxide has 6. This is because they have different molecular formulas. The molecular formula is the regular formula that we are often most familiar with. The molecular formula shows the total number of each type of atom and can often be simplified down to an empirical formula. The molecular formula for nitrogen dioxide is the same as the empirical formula, NO2, while the molecular formula for dinitrogen tetraoxide is a multiple of the empirical formula and is N2O4. A molecular formula is always some multiple of the empirical formula. So, for nitrogen dioxide, NO2, the multiplier, N, is equal to 1 because the empirical formula times 1 gives the molecular formula. A similar operation can be done for dinitrogen tetraoxide, where N is now equal to 2, as 2 times the empirical formula gives the molecular formula of dinitrogen tetraoxide. Let's check comprehension.